Alright, this question is asking us what is the measure of angle JLK. So that would be this angle. JLK is this angle because when they named them, the center letter is the vertex of the angle. This is a triangle, so we also need to know that the three interior angles of any triangle will add up to 180 degrees. Put that right here. But the issue we have right now is that this angle and this angle could be any two numbers that are going to add up with 62 to get us 180 degrees. Um, so if we could figure out some other things about the triangle, then we might be able to determine these angle measures. I think some people might just immediately assume that we could just find 180 minus 62 and divide the result by 2, and that would be these angles, but we don't necessarily know that they are the same measure yet. They could be, but we have to check first. So this side of the triangle is completely vertical, so we can just count that it's 1, 2, 3, 4, 5, 6 units. So I'll put the 6 right here. These sides are not vertical or horizontal, so we're going to have to use the distance formula to determine their length. We're going to use right triangles. So this is 3. This side is 1, 2, 3, 4, 5 units. So I can use 3 squared plus 5 squared and square root that. Pulling out the calculator, which is hidden because it's huge. 3 squared is 9 and 5 squared is 25, so we add those together to get 34. So this side length is the square root of 34, which is irrational, so I'm just going to put that for now. We're going to do the same thing over here. Kind of a shortcut is when I make my right triangle, this side is 3, this side is 5 again, so I don't really need to do the calculations because we had the same right triangle up here that was 3 units and 5 units. So that means that this side JL, is also the square root of 34 units long, which means that this triangle is an isosceles triangle. These two sides are the same length. KL is different. So that is going to tell us something about the angles, which will be helpful. So I'm just going to mark some new things. Now that we know that these are the same length, that tells us that these angles are also congruent to each other. That is a property of isosceles triangles. These two base angles are going to be the same measure. So if you were assuming at the beginning that they are the same, you were correct. 180 minus 62, pretending I'm not going to use the calculator to do that, 180 minus 62 gives us 118 degrees. I guess one way we could look at this is that 62, and put it down here, 62 plus 2x is 180. Right, x could be our angles, our angle measures. So we just took away 62 from both sides, and now we have that 2x is equal to 118, as in our two angles added together adds to 118. So I can just divide both of these sides by 2. That tells me that x is 59, because 118 divided by 2 is 59. So that means that angle JKL is 59 degrees, as is this angle. And just if you really wanted to make sure you're correct, we could add our three angle measures together, make sure they add up to 180 degrees. 62 plus 59 plus 59 equals 180. So our answer is C,